Hello everyone, welcome back. In this class, we'll learn about uniform accelerated motion, one of the important concepts in IBDP mechanics. The acceleration is whenever the object is changing its velocity. If the object is changing its velocity, we say it's accelerated motion. On the other hand, if it is not accelerating, it's covering equal distance in equal interval of a time. So we use this form. So if I'm saying a car, 15 meter every 1 second, and hence it'll keep covering 15 meters every 1 second. I can say the car is moving with constant velocity if it is moving in the same direction. If the object is accelerating, so how do I solve the problem based on accelerated motion or like specifically uniform accelerated motion? So in that case, I'm going to use the Suvat equations or UV-SAT. So I can call it as Suvat equations or like kinematics equations. So in this kinematics equation, the u being the initial velocity, which is measured in meters per second, v is the final velocity, again measured in meters per second, a is the uniform acceleration, which is the rate of change in velocity, which is measured in meters per second squared, s is the displacement, which is termed as like meter, time being seconds, time SI unit for the time is seconds. So these four equations are given in the data booklet. We use these four of them whenever there is a uniform acceleration. Let's say if we have this graph of displacement versus time, and if I have this shape graph, I can say at the maximum displacement at this point, the slope of the graph will be zero, and I can say that velocity is also zero. That's what the velocity at the maximum height will be 0 meters per second. You can see the graph was much steeper in the beginning and getting less and less steeper. So the velocity is decreasing and then velocity starts increasing after that. So I'll always write down this S U V A T and I read this question and I figure it out what variable is been given in the question. And if the variable has been given, I write it down. And if the variable is unknown, I'll mark this question mark. So in order to solve this accelerated motion, you need to have at least three variables known. And even if there are like two variables are unknown, you can still solve using the set of these equations. And I see this, a car is initially moving with the velocity of 5 meters per second. So initial velocity is given as 5 meters per second. After displacement of 20 meters, the displacement is 20 meter. Its velocity becomes 7 meters per second, so its final velocity is 7 meters per second. Find the acceleration of the car. So we need to find out the acceleration of the car. So now we know S, U, V, and then A. So the equation which is connecting between them is V square is equal to U square plus 2AS, which is also called as this timeless equation. We don't need the information about time. Timeless equation. So if I plug this value, if the ball is dropped from the height of a cliff of 40 meters, with what velocity it will hit the sea. So over here, if I solve for S U V A T, what variables have been given? So since the ball has been dropped, its initial velocity has to be zero. So U, I can figure it out, it's 0 meters per second. I'm solving it for the V, so that's unknown. And its displacement is 40 meters, so it's 40 meter downward. So I can put that S to be minus 40 meter. And since it's falling freely downward, its acceleration has to be acceleration due to gravity. So minus 9.81 meters per second. and I need to solve for the v. So again, time information has not been given, so we don't know that. I can use the timeless equation again. So v square is equal to u square plus 2s. It has to be, so u is 0, so I put 0 square plus 2. The acceleration is negative 9.81 into the s, which is minus 40. We can solve this. So the v is equal to 19.80 meters per second. It's the final velocity with which the ball will hit that C. In the same question, if they ask you uh, what will be the time taken to hit the C, so we use the same form as UVAT. Like I'm solving it for time to hit the C. So in this case, I'm looking for the time. The displacement is still 40 meter negative. Initial velocity is still 0. V, I have already got it as negative 19.80. Why negative? Because it's going downward. So I can use V is equal to U plus 80, and you can solve for the time as well. So minus 19.0. If I can solve this, get around 2.01 seconds, which is roughly like 2 seconds. So that's the time when it will hit the C. So using this kinematics or Suvat equation, we will be able to calculate um, any of these variables SUVAT if you use the appropriate formula. Let's solve this question. Let's practice this. So in order to solve for the maximum height, what are the terms given over here? So the ball is thrown vertically upward with initial speed of 20. So it's u has been given as 20 meters per second. From the edge of the cliff, that is 25-meter height. So the total displacement has been given as 25 meter, and total displacement has to be negative. V is the final velocity. So in order to solve for the maximum height, to solve max height, so when the ball reaches the maximum height at this point, the final velocity has to become zero. Acceleration is given as 10 meters per second square, and then time is also unknown. And I can't use this information because that's what I'm calculating. So in order to solve for the max height, this S is what I'm solving for. V square is equal to U square plus 2AS, and then V will be 0, U is 20 meters per second initially, plus 2 into minus 10 into the S, which is I'm looking for. So that becomes minus 400 upon minus 20, which is equal to the S. So S will be equal to 20 will be 20 meter. That's the displacement, maximum displacement or maximum height from the cliff. From the cliff. So we got this height to be 20 meters. Now, in order to solve the time taken to uh, ball to reach the maximum height. So in that case, I'm going to use V is equal to U plus 80 because again, I know that V is 0 at the maximum height, U is 20, acceleration is 10 meters per second square. Again, it's going up to negative, and then T is what I'm looking for. So this turns out to be 0, 20 times minus 10 into T, which turns out to be T is equal to 2 seconds. It takes 2 seconds to reach the maximum. Then they're asking time to hit the C. Okay, this is a really important part. So time to hit the C, time to hit the sea. So in that case, the ball is launched from this cliff. It'll go up by 20 meters, returns down, and then this. So throughout this, the total displacement will be minus 40 meter. So what I know the SUVAT, I know the total displacement is minus 40 meter. Initial velocity is 20 meters per second. Final velocity, we don't know with what velocity it hits the sea, so we did this is unknown. The acceleration is still minus 10 meters per second square, and this time is what I'm looking for. So if I write down this equation, that S is equal to ut plus 1 half at square, and I plug this value as minus 40, which is equal to the 20t plus 1 by 2 into minus 10t square. If this turns out to be quadratic, you will be able to solve these two values with the t. These are for t. One of them will be the 5 second, other will be some negative number. You can solve it. So the total time of flight will be 5 seconds, in which you can break this down to be 2 seconds to while going up, 2 seconds to return back to the same spot, and it only takes 1 seconds to follow from the downward motion to 40 meter down. Now, in order to find the last part of it, the speed with which it hits the sea, the speed, the final speed. So for that, SUVAT. Now we know the total displacement is also minus 40 meter. Initial speed is 20 meters per second. Final speed is what I'm looking for, and then acceleration is minus 10. I also know the total time is 5 seconds. So I can use any form. If I use V is equal to U plus AT, then final speed turns out to be initial speed is 20, acceleration is minus 10, make sure you use minus 10, and T is 5. So that 20 minus 50, which turns out to be minus 30 meters per second. And so they're asking me the speed. So we will write 30 meters per second. The minus sign over here indicates just moving downward. They're asking you only the speed, so the magnitude of that quantity, and it will be only 30 meters per second. So hope you understood this.